This chapter is all about the topic of NLU, or Natural Language Understanding. NLU is a subfield of Natural Language Processing, NLP, and is usually concerned with transforming free-form text into structured data within a particular domain. For example, a restaurant booking bot should be able to understand a sentence like, "I'm looking for a Mexican restaurant in the center of town." It should then query a database or an API to find matching results. To do this, we need to identify the intent of the message and extract a set of relevant entities. An intent is a broad description of what a person is trying to say. For example, hello, hi, and yo 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 are all ways that people might greet your bot. The example sentence I just mentioned could sensibly be described with the intent restaurant search. There are many different ways someone might express this intent. For example, I'm hungry. Show me good pizza spots. I want to take my boyfriend out for sushi. Now, there's no universally correct way to assign intents to sentences. The correct answer depends on your application. For example, if you expand your bot's capabilities so that it can actually book a table for you, the final sentence, I want to take my boyfriend out for sushi, might be better described as a request booking intent. The second part of the NLU problem is to extract entities from the text. In the restaurant search example, this means correctly identifying June 10th as a date, sushi as a cuisine type, and New York City as a location. A well-studied problem in NLP is named entity recognition, or NER. This is almost exactly the same problem we're describing here. The difference is that NER usually aims to find universal entities, like the names of people, organizations, dates, etc. In the case of bots, you often want a narrower definition of your entities that are specific to your domain. In the next couple of exercises, you will build regular expressions for recognizing intents and entities. This is much simpler than the machine learning approaches we'll use in later parts of the chapter, and they're highly computationally efficient. The main drawback is that writing and debugging regular expressions becomes really hard as your chatbot becomes more sophisticated. We will use regex to look for keywords in text. We can build expressions which match any one of a set of keywords by using the pipe operator. This corresponds to the logical operation OR. Remember that we can check if a string matched a pattern by checking if the returned match object is none. For example, to look for the keywords hello, hey, or hi, we can write hello, pipe, hey, pipe, hi. Notice, however, that this is just a string of characters. So hi will also match the words which, this, etc. We can add the word boundary expression, \b, at the start and end to indicate that there shouldn't be any alphanumeric characters on either side of our keyword. Notice that we've put an R before the start of the string. This creates a so-called raw string, which means that we can include special characters like the \, without clashing with the default Python string behavior. If we're going to use a pattern multiple times, we can create a pattern object using the re.compile method. The pattern we've defined here uses some new syntax. Square brackets, for example, indicate a range of characters. As before, the asterisk means 0 or more occurrences of this pattern. So the final part of the expression means 0 or more lowercase letters. The first part of the pattern matches exactly one uppercase letter. So this pattern will match any capitalized word. The findAll method of the pattern object conveniently extracts all the matching substrings. So to find all the capitalized words in a sentence, we can run pattern.findAll, passing the sentence as an argument. Now it's your turn to write some regular expressions and use them to get intents and entities from the messages your bot receives.